Okay, so now we're going to do some examples. So here we're asked to evaluate this expression here. So you want the integral between 1 and 4 of 9 minus 2x to the power of 3 negative 3 dx. So what you want to do here is you want to check, is it in a good differentiate form? Yes, it is. Everything looks good. So we can just start off by saying 9, increase the power by 1, which would be 1, divide by that power, which would be 1, minus 2x to the minus 3. So we want to increase this power by 1, so that becomes minus 2. And then you want to divide by that power, so that is minus 2. So these cancel out quite nicely. That becomes a plus. And you're going to put in your limits here. So this becomes 4 and 1. So now you can start to substitute in your limits. So this becomes 9 times 4 plus 4 to the power of negative 2. And you're going to minus the lower limit here. You substitute that in. So it becomes 9 times 1 plus 1 power of negative 2. Okay, so what does this become? This becomes 36 plus, we could think of this as being 1 over 4 squared, so plus 1 over 16. 16 minus 9 plus 1 is going to be 10, so this becomes 36, well, it'll become 26, won't it? 26 plus 1 over 16. So what you can do is you can times 26 by 16, which would give you 416 over 16 plus 1 over 16 equals 417 over 16. That's your answer. On to the next question. Integral between 0 and 1 of s to the power of 2 over 3 ds. Same thing again. So we want to increase the power. So this becomes s to the power of 2 over 3. Increase it by 1. Right, so that becomes 5 over 3. Okay, and then you want to divide by that power. So the 5 stays there. But the 3, which would have been there, actually comes back up. And you're left with this. 3 to the power 3 times s to the power of 5 over 3, divide 5 between 1 and 0. So what does this become? 3 is equal to 1 to the power of 5 over 3 all over 5 minus, well, everything here is dependent on 0, or on s, so actually this becomes 0, so this one should becomes a fairly easy problem to solve. Okay, so 1 to the power of 5 over 3 is going to be 1, so your final answer is going to be 3 over 5. That one simplified quite nicely. Okay, so next question, we're asked to evaluate between 1 and 3 for the function 5 over x squared dx. So the first thing we want to do here is get this in the correct form by moving this x squared to the top. So this becomes the integral of between 3, oh, my pen's gone funny there, integral of 3 and 1 of 5 times x to the negative 2 dx. We can actually take this 5 out because it's a constant, so this then becomes 5 is equal to 5 multiplied by the integral of x to the negative 2 dx. Okay, so now we can start to integrate this. This becomes x to the negative 1 over minus 1. Okay, between 3 and 1. So it looks a bit like this. So we can keep the 5 here, and this is all going to be times by, well, this can be rewritten. I'll rewrite it because it looks a little nicer. So this can be the same as 5 times -1 over x between 3 and 1. So I'll change colour to substitute in the limits. So this becomes 5 times -1 over 3 minus -1 over 1. Okay, so this becomes +1, so this becomes -1 over 3 plus 1, which becomes +2 over 3, so this is 5 times 2 over 3, which is equal to 10 over 3, and that's your final answer right there.